Hello everyone, I am Ashudan Ardakar, the leader of Team Proton, and this project has been created by my teammate and myself. My teammate is Apurva Javankar, who is studying in the same college, and the title of our website is Climate Pattern Analyzer and Predictor. So here we have trained this model with a pre-built dataset of air quality index. So now we have feed the data and it has red. So here four tabs will appear. First tab is of 2004 to 2005 trends where we see temperature, gases and humidity trends. It is a temperature versus date graph and you can see all the line graphs related to the gases. Our second tab is monthly influence. That means if the temperature was at X in March and it has turned to Y in April, then what were the reasons, most influential reasons? So if I, for example, select here May, then the graph will update and change from May to June. We can observe here that the most influential reason was due to absolute humidity, which had a significant amount, which is 49.07%. And for the same, graph has been plotted. Here we have extra feature, which is a virtual view. So what will happen if I change certain values? Then will my temperature change? So as we see, absolute humidity being the most influential, if I take it to 0.8 value, it increases by this certain amount. Let's keep it at 0. And with the least influential value, we'll take it to the same bar, 0.8. And we can see that the change is almost, okay, wait, I need to- and if we make change in NO2, then the graph will update almost negligibly. How it works, each slider is ranges from -1 to 1 and the impact, that is the estimated temperature values, depend on the factor's range and how much influence does this factors cause on this temperature, and total temperature is limited to plus minus 5 degree. So we'll move on to our third tab, which is 2005 prediction. That is 2005 values are being predicted and this model is trained with random forest on the dataset of 2004 year. These are the error values and this is how the graph looks. The graph will not show a significant change because of small window of time. However, if the randomness is increased, the graph will slowly turn more curved. And in the if we select the option extended future, here we can see that absolute humidity is the most influential in terms of future prediction for the temperature. And here we get extra option, which is prediction uncertainty. So if we increase this prediction uncertainty, then the prediction done by this model will dissolve a bit and the shaded area will increase. It states that the temperature can rise instead of this from here till here and from till the lowest from this point to this point. And here we can see the table of annual temperature summary for years 2006 to 2010. The model has been trained on 2004 and has been tried to predict values from 2005 to 2010. The average temperatures, mean temperature, maximum temperatures, and these are the details of the prediction model. We will move on to the fourth tab, which is our main feature here, which is the real-time data and influence. So here, for example, if we select any random city, which is Hyderabad, and press the button fetch real-time weather, then the backend code fetch through the API fetches data and it maps onto old data set and finds out the most influential thing that changes the temperature or changes the climate in Hyderabad is wind speed. Here we can see the data. Thank you.